Hello. So in this video, I thought we could just practice a little bit with the trigonometry that we've learned so far. So let's say we have it's a bit bent, but we have a flagpole here. I'm not sure exactly if this is what a flagpole should look like. A nice little flag. This is one of the most obvious questions. And we are standing, say, here's us. We're this little person. We hold our shoulders really weird and hunched. We are standing a good 5 meters away from this flagpole. And we are looking up at this flagpole. We're looking up at this flagpole at an angle from, a flat line straight out from our eyes, at an angle of 30 degrees. Okay, so how can we determine the height? And let's say our height is 2 meters. Tall, but not too tall. So how can we determine the height of the flagpole? Well, let's break it up into two parts. We know that from here, let me put a little dotted line across here. From here, at this point, we're at 2 meters. And then we make a triangle with our eyes to the rest. So we should be able to use a trigonometric ratio to solve this problem. So we know one side of this triangle, this side, this is 5 meters away, right? And we know an angle, 30 degrees. And that's all we need, right? Because if we know all the angles, by knowing one angle, we already know this angle. We know angle, we know all of them, because 180 degrees is the total number of degrees in the triangle. And we know one side, knowing the ratios, we can find all the other ones. So which one could we use? Well, we're dealing with the adjacent side. Let's pull up SOHCAHTOA. SOHCAHTOA. So which one has adjacent in it? This one has adjacent. Adjacent over hypotenuse. We don't know the hypotenuse. We don't know the distance from our face to the top. So that's not useful. What about this one? This is opposite over adjacent. Hey, we know adjacent, right? That's what we're looking for. And we don't know opposite either, but we are trying to find it. Sorry, this one was not important because, for one, we didn't know this one, and we already knew adjacent. This one, opposite over hypotenuse, wasn't good because we don't know either of them. In this one, we know adjacent, but not opposite, and the angle. So we should be able to do the tangent. Let's try. So the tangent usually is denoted lowercase of 30 degrees is equal to this height here, h, just from here, stretch that, is equal to opposite over adjacent, h over 5. Now just solve for h. H is equal to 5 times the tangent of 30 degrees. Alright. So is that simple? So what is a tangent of 30 degrees? Well, we're going to go over this in great detail in the unit circle videos. For now, I'm just going to tell you. It is 1 tangent of 30 degrees, which doesn't have to be in parentheses technically. I believe it's 1 over the square root of 3. Yep, that's it. 1 over the square root of 3. So, our h is equal to 5 times 1 over the square root of 3 or 5 over the square root of 3, which is enough simplification. If we want more, we can always do, 5 square roots of 3 over 3 if we want, by multiplying the numerator and the denominator by the square root of 3. But this is fine. And it's that simple, except there's one more bit. That's only this part. That's only, let's switch colors. That's only this part of the flagpole. We also have this other part, but that's easy. We know our height, 2 meters. So, it's actually going to be plus 2 for the height of the flagpole. So the height of the flagpole, is equal to 2, okay, 2, right, 6 over 3. So 5 times square root of 3 plus 6 over 3. And you can use a calculator to find that value, but that is it. That's a constant. We know the height of our flagpole.